Hello everyone, welcome in this introduction to Python workshop. So before beginning, I'm going to explain what kind of library we'll need. So for this workshop you will need of course Python, but you will need also several libraries, and you can either install all these libraries one by one, or you can just install what we call distribution that contains plenty of libraries already built in that are going to be useful for us. So the distribution which is the most common is called Anaconda. So how you can find Anaconda, you just need to type Anaconda Python and you'll find the first link normally will be the Anaconda distribution. You go on download here, you choose, sorry, I'm going to enlarge it, to maximize it. Okay, you choose your distribution, normally it detects it automatically, and be sure to install the Python 3 version. So you click on download, you install it on your computer, and it depends on if you are on Mac, on Windows or Linux, but please follow the instruction to install it. It takes a while, so be sure to have everything installed before beginning. Okay, so maybe I can begin with the first slide then. Okay, so my name is Bruno Dessau. I will teach this 3-day machine learning with Python workshop. I'm glad to have you. If you need to send me a mail, here you have my address. So just to mention the slides, the workshops have been at first created by Thiago Moscario. I have taken back his slides, changing plenty of things, but I would say the core of the course was made by him. It was a very wonderful job, so I thank him for that. And something which is very important for you, I guess, it will be the website that contains all the slides. Because as you will see in the workshop, I will basically have the slides open here, and here I will have what I call my notebook. So maybe that won't be written it won't be very largely written here on that slide. So be sure to have the slides open, and then you can zoom in and see the code I'm writing in that notebook here. So the slides you can either copy paste or copy this address in your navigator, but most of the time, so I'm going to Google here, most of the time if you just hit like QCB Collaboratory, Collaboratory UCLA GitHub. Normally it should be the first link here you have. You can click here. You have, if it works, yeah. So here we have plenty different workshops. Just go on machine learning workshop here. And here you can access to the last version of the slides around here. So here I click on day 1 and you can download it just by here. It would be a Google Drive workshop, and you can download it without any problem hitting that button. So that would be normally the up-to-date slides. Okay, so be sure to have that download, so you can look at it when you need. And let's continue. Okay, so what is machine learning? So here you have a citation, a quotation from a father, from one of founder of the machine learning. He says that it's a field of study that gives computer the ability to learn without building explicitly programs. So basically, it's not like usual programming, like maybe some of you did the introduction to Python workshop on the Collaboratory. If you did that, you see that we say explicitly to the computer what to do. In that case you do that, in that case you do that, in that case you do that. Machine learning is slightly different. You are more like a guide. You guide the computer into what he has to do, and the computer will learn from the data and just a guide to make it understand what to do in case of the data are slightly less. So the computer, in a sense, is more free. It's represented by this cartoon here. The computer here reads the data and tunes itself in order to corresponding to the data, and you are just more like an extra step above, saying how it has to tune itself in case of those data and those data. So it's kind of a little bit of abstraction rather than explaining everything that the computer has to do. Okay. So basically we'll do that in this workshop. So it's a very large definition. We will not see everything of it, but still it's pretty much what we'll do, as you see. What is the goal of the workshop? So it's not, as I just said, to give you to make you learn everything you have to learn about everything that is known about machine learning, because first of all it's still changing topic, so there's new things every week and it's very large. But the idea is rather to give you the, what I would say, the basic knowledge, and most importantly the good practice, and you'll be still at the end of the workshop capable to do plenty of things, to build some models for plenty of problems. And when you need to apply it on your particular problem, then you can have the help of Google, of those two websites, which are websites where we ask questions and people answer, and you can see the questions of others. So when you have a problem, usually somebody already has the same problem and ask the question on either one of the two websites. So Stack Overflow is more general for programming. So if you have a question about Python in general, things like that, you will find it rather on Stack Overflow, and you cross-validate exactly the same kind of website. It's just that it's more dedicated to machine learning. Here I will explain what are those books, those resources. You can also have a look into them. It's a very good book in order to do machine learning, and at the end you will need to you will have a model that will work, so we'll be happy like this baby here. Okay, so just an overview of the workshop. So on the first day of the workshop, I will mainly at first, in the first half of the workshop, I will give you what the tool we are going to use for this workshop. So it will take a little long time, but I think it's interesting. And even if you don't do machine learning, but you want still to use Python for a scientific application, all those tools will be very useful for you. I will give you the motivation, then the first introduction to machine learning. We'll do an example. Tomorrow it will be dedicated to classification and cross-validation. And at the end, it will be we'll speak in the last day about regression and non-supervised learning. But first today, so the fundamentals and motivation. So I will just make a quick review on Python. You're supposed to already know the bit of Python, or at least you have already programmed in the language. If you never did Python but you program in another language, you just need to follow. Everything will be written, so you can just copy and try to understand how Python is working. Of course, it's better if you already did a little bit of Python. Then I will introduce the Jupyter Notebook. I will explain what it is, what kind of very useful tool it can be. It's where we are going to write our code rather than using old-fashioned console, Python console or Python script. We'll write Python, what we call a notebook. Then I will explain what is NumPy and Matplotlib, which are general libraries for scientific application of Python. NumPy will contain an object that can to represent the notion of vector, so very useful for scientific application. And Matplotlib will be an app in a library to plot some figures. Then I will introduce to classifier, and I will introduce you to a last library, which is scikit-learn, which is dedicated to machine learning. Okay, so let's continue. Okay, so let's talk about Jupyter and Python. So what is Jupyter? So Jupyter, Jupyter Notebook. What is a Jupyter Notebook? So it's an open source application that allows to create and share documents. So you can imagine that to be the same kind of things as Microsoft Word. The only difference is that you can write some Python code and execute it. So you have a single file that you can send to somebody else, but this file will contain some Python code. So let's see why we need such a tool. So for now on, if you follow the introduction to Python workshop, we used the console. So the console is here by default. As soon as you install Python, you have access to the console. If you access to server or remote a cluster, or remote computer via SSH, maybe you don't have the graphical interface, or the graphical interface is not that quick. So maybe you just have access to the terminal there, and then you can open the console very easily. It's very rapidly available. Just have to open a terminal and hit Python 3, and you have access to the console. The cons is that it's not shareable. Since you have done something, as you have done something on the console, you cannot take a file that contains all the commands you have written and just send it to somebody, to your colleagues or your PI. It cannot plot some figures, so it's not a very nice tool for scientists who like to plot some figures, and it's not ergonomic at all. As you have seen, it's very annoying when you do a for loop and you made a mistake, you need to retype everything. It's quite annoying. So because of that, some people have created another tool which is called Notebooks, which has plenty of advantages. First of all, it's shareable. You can take, it's just a single file that you can take and send to somebody else, to your colleagues, to your PI. It can plot figures, very nice figures, inside the notebook itself, and it's user-friendly. You see that it's very easy to write some Python code and you change it. The commands need to be installed. It do not come alongside with Python 3 together. So it's why I ask you to install Anaconda, the Anaconda distribution that contains plenty of scientific Python libraries, including Jupyter. And also it's not very suitable for very large projects. If you have tens of thousands of lines of code needed to write a simulator, maybe the Jupyter Notebook is not the best tool. But for very short projects like what I'm doing right now, the teaching and all the data analysis, then it can be very useful. You can just plot some figures. You have some data set, let's just imagine. You can plot some figures. You can, if you show that your PI, you can then change to, and he or she asks you to change one of the things, you can do it very directly. It's very convenient for that. So we're going to use this tool, and you will see that it's a quite nice tool. So to do that, I ask you to install Anaconda, and Anaconda come with what we call Anaconda Navigator. So what is Anaconda Navigator? You can imagine like Google Play on your tablet or iTunes, I don't know, where you can just point and click the software you want to launch. So in order to open that, if you're on Mac, you just hit the button command space. You have the search bar, and you just hit Anaconda, and you will see Anaconda Navigator appear. If you're on Windows, you need to look on your start menu, and you should have something like this. So since I'm on Linux, it's slightly more technical. I need to open a terminal and just hit Anaconda Navigator. It takes some time. Here you have the thing which is appearing, and then you have this object which has been launched. Okay, let's see here. Okay, so you have plenty of small software. You don't like a dozen of it. We will use only this one, Jupyter Notebook. Just need to click to launch the Jupyter Notebook. Just a side note here, you have something called Jupyter Lab. It's just like you you could say that's a new version of Jupyter Notebook. It's mostly the same thing. If you are curious at some point, you can just click on that and see that it's almost the same thing as Jupyter Notebook. It's just that all the screenshots of my slides are made with Jupyter Notebook, so I'm going to use this one. But if you are curious, please have a look at Jupyter Lab. So you click here on Launch. You might have on your computer just a terminal opening with plenty of stuff. Don't care too much about it. This is not that much important. You just keep it open. Keep the terminal open because it's the underlying terminal on which the Jupyter Notebook is running, but just put it aside and don't care too much about it. You should have another Windows which is opening here. So here, for example, have a new Windows, and you can see maybe you can recognize that is in fact your navigator. So me, I'm using Chromium here. You might have Chrome, or you have Internet Explorer or Firefox, whatever. Just opened the web navigator, which is quite strange because we are not accessing to something on the internet, right? So in fact, you can just see something here. If you see the address, it's not like HTTP www something. It's just like localhost with some numbers after that. Localhost means that it's a website running on your own computer. So if you have another computer there and you hit that that address, you won't access to your thing. So it's something which is running on your computer. Your computer is in server to itself, etc. Why is that? Is because for compatibility issues, the team behind Jupyter didn't want to maintain a version of Jupyter Notebook for Windows, for Linux, for Mac, for the tablets, rather than having that, since all these platform has the common thing to have all of them that have at least a web navigator which is running. They prefer just to make something that runs into the web navigator, and it's much easier for them to maintain that. So it's why it's running inside your web navigator. So how is it organized? So here you are in Jupyter. Here's something like file running cluster, and here you have, in fact, it's your own file. So if you open Finder on Mac or Explorer on Windows, it will be your documents here. So here you have my documents, I have images, pictures in English, music, etc. So you can navigate. It's relative to your home directory. So for example, if I click here, hopefully I will go into my documents, and I can even create new new objects. For example, I can create here new folder here, and I will have an untitled folder created here. I can rename it, rename here, and I would call it, like, for example, machine learning workshop, something like that. And I can click here. I have an empty it's an empty directory, of course I've just created it. So what we are going to do is to create a notebook. So in order to create a notebook, you need to click here on New, and you will have plenty of options. So here I've already created a folder. You could have created a text file, you could have opened a terminal, but what we're interested here is in notebooks. So you have plenty of, you might have only one possibility for a notebook, like Python 3. We have other thing of other what we call kernel available for Python 2 or for Julia. You have to imagine that the notebook tool, even if it has been at first created dedicated for Python, now it can run with plenty of the languages. And for example, you can run it with R. For that, you need to install what we call a kernel. So you can go on the website. It will explain how to install the R kernel, and you have to imagine that everything we do with the notebook with Python 3, you can do the same with all other languages like R, or we have like Julia, which is another programming languages, or with Python 2. I'm going to use Python 3 here. Okay, So let's click here. It opens a new tab here, and here it comes. So what do we have here? So it's kind of, it's a little bit like you have file edit view like any usual softwares. So if you file edit, so you are not lost. Here you have the title of a notebook. You can change it, like say machine learning workshop day 1, something like that. So it has entitled the notebook. If you don't have this toolbox here, you can just hit view, toggle toolbar, and then you have this toolbox available here. Okay, so basically I've explained what it is here. So what is this thing here? You can see here you have, like, when I click inside, you have a green rectangle and something here. It's what we call a cell. A cell is a place where we're going to write some code inside. So yeah, we're going to write things, and especially we're going to write some code. So let's try it here. Let's write some code. So for example, I'm going to write some Python code. X is equals to 5 times 3 plus 2. So you can see there is a syntax highlighter, like it's recognizing it's using Python. So all the keywords like def to define a function, for, if, etc. will be highlighted. So it's quite nice. So once we have done that, we can run the cell. So make Jupyter execute the cell. To do that, you have two ways of doing it. You can either hit the button run here or shift return. So shift enter. So let's run it. Okay. So we executed it. You can do either click on that button or use the shortcut shift enter. Okay. Okay. So what's happened? What happened? So there's a few things which are changed. Now it's in with a square bracket here, 1. Why is that? In is for input. Maybe on your computer, if you are a student with a foreign language on computer, you might have something else here, which is something for input. And square brackets, where here's the number. So that means that this line here, this cell, has been the first one to have been executed. It will have some importance later. And then that did something and created a new cell here, ready to have a new code writing here. Yeah, so basically executed this cell. Since it didn't print any error, it means that everything went right. Okay. So let's write something else in the second cell. So we can write multi-line cells. So that's an advantage compared to the console. So here I can write y is equals to 7 times x squared plus 0.6 times x. Oh, sorry. And I can here hit just return, not shift return, but just return. It'll give me a new line in the cell. So I can say 1 divided by z. 1 divided by z. And I can do at the end x times z. I execute the cell, so here I will hit shift return, for instance, so you can hit that button once again. Shift return. Oh. I did a small mistake here, so it says that there is an error, and I can see what it is. I did 1 divided by z rather than that 1 divided by x. So I executed it. So what happened here? So the in changed. So here was in 3 because I made a mistake just before. If I didn't make the mistake, it would be in 2. And now you have what we call out for output, and it's the output corresponding to the third cell executed. So here is 2 because when I was writing that, I made a mistake. So the 2 was the mistake, and 3, the third cell to be executed, is this one. Okay, so why do we have an output here and we don't have it here? So it's exactly the same thing as in the console. In the console, if you write x or whatever equals to something, then it does not display anything. If you don't have that, it will display the last thing that it tried to execute. So here have x, y times z. It displays things. So if you want to display thing not at the without putting it at the very end, you can do it in another way using the print statement, right? So let's do it. Let's just for now create a range up to 10. So all the number from 0 up to 10 without including 10. And let's write new a new line, and I will do a for loop for elements in x. I'm going to print. You can see here that it automatically put me the indentation because it knows that I'm writing some Python code. And here to be elements, and I'm going to print elements. So we'll go through each element of x and we'll print it. Is what we will have here. So here it uses the print statement, so it's not an output, but still it displays everything. I won't explain what is the difference between an output and just a print statement. You can see it's two ways of displaying things. Okay, so cool. Let's continue. Okay, so execution order. So let's make a test here. Let's imagine I want to go back to that cell here, the second cell that we have written. I click and just hit shift return and see what's happening. Oh, there's a mistake. What? Well, there's an error, sorry. Why is there an error, as you can see? So here you have a hint. So since I did a mistake, an error at the very beginning, the count is shifted, but you can see that there's something wrong here. So it means that the fifth cell to be executed, and below here is the fourth cell to have been executed here. In fact, what happened is just first you execute this line at the very beginning, then you execute this one, this cell, and knew what was x. X was defined before, and then we execute this cell here, and we redefine x as being a range, and then we try to execute this cell again, and here it says I don't know what is the power of a range. I don't know what it is. So it's why there's an error here. So be very careful. It's not because physically on your notebook you have one cell above the other that it means that it has been executed before the other. The order of the cell, the order in which the cell are executed is given you by the in and the number which is here. Okay. So the idea behind that is you have your notebook which is communicating with a hidden, what I will call a hidden console. You can imagine that as being console, but just hidden, you can see it, and when you hit write something, some code here, Jupyter will ask to, we send the instruction to the hidden console and will receive all the output and will display it. For example, here, the first thing I executed was x equal 5 times 3 plus 2. Then I executed this cell here, then execute this cell here, and then come back here. So for the console is linear, and here it's whatever the order you ask it. Okay, so this you can imagine as it as a hidden console, what we call the kernel. So let's imagine that at some point, yeah, so basically I'm explaining here what happened. First you send to the kernel this cell, then this cell, then this cell, and then you send a new this cell here, and in between the x has changed, so that's why there is an error here. So when you go back above in your notebook, be sure to run all the relevant cells. Let's imagine that you have like several dozens of cells. You are kind of lost. You don't remember which cell have been run, which one are relevant. And you want to just clear everything and start over once again. So in order to do that, you can go in the menu called kernel here. And you have plenty of options. So you can restart. If you do restart, it's just as if you go out from Python and start all over again. So it forgets all the variables. You can have restart by clear output, so you do exactly the same thing. We restart the notebook, restart the kernel, and also it will remove all the display, all the print statement and whatsoever. You remove all the number even in. So usually it's this one where we can use, or this one which is restart, and we will run all the cell in the order of the notebook. Okay. Don't care about those. Here you have another one which is interrupt. So when you're on a console, you are kind of a trap into an infinity loop, and in order to get out of it, usually we use Control-C to make a keyboard interrupt. Here, since Control-C just copy paste, we just have a button which is kernel interrupt. So if you're kind of lost, trapped into an infinity loop, you can hit kernel interrupt and do exactly the same thing. Okay. Okay. So let's for example to restart and run all. Yeah, I'm sure I want to do it. And restart and run all. Okay, in the right order. Okay, so now we are going to add some text command, which is, I think, the more important aspect of the notebook, the thing which is make it very useful. You can write plenty of comments very easily using Jupyter Notebooks. So let's go here, let's click here, and here you have insert cell above, which is quite straightforward. It inserted a cell just above. And here we are going to change the type of the cell. So you can go either here, or you can go into cell type and change it. So code is when you want to write some Python code, and Markdown is when you want to write some comments. So just text if you want, with a little bit of formatting, and don't care about the last one. So let's hit Markdown. So we are going to write back some comments into that cell, so it removes the in, because it's not something which is executed. Okay, and let's write some text. Let's write some comments. This is some text. We can even use formulas, so whatever you want, and you can write with LaTeX syntax some formulas. So for example, here I'm going to write theta is equals to a fraction. Add the numerator, it will be the concentration of L to the power of n, and denominator to be K D plus the concentration of L to the power of n. On this, under the impression that there is a spelling here, it should be a capital L. It won't change that much. If you execute that, I did theta. You will have the text which is displayed, and the formula which is displayed in a nice way. You can even put some titles, so the syntax for so it's what we call Markdown syntax. It's just an easy way to format things. So for example, you can write some title. This is a title using the hashtag symbol at the beginning. You can write italics. This is italics. So you put just a star in, before and after the thing that you want to put an italic, or in you put 2 stars to bold. You can even put some images. So here, this is the title, italics, in italic and bold. You can even put some images. I will just let you go on internet and see, hit Markdown syntax, see all the things you can put. You can put tables if you want, etc. So you can arrange your notebook in such a way that it can be very easy to understand for somebody else who is reading your code, or even yourself in a few months. Like you are writing some code, and in a few months you open once again your code, you will be very happy to have those kind of comments where you explain what you have done. And it's a very nice tool, and it can be very like reports very easily of data analysis, for example. So it's very cool for that. Okay, so I won't go too much into the detail. I will let you discover the wonderful world uh, of the notebook. Okay, how to save your notebook. So your notebook is saved most of the time automatically. Just to be sure that it is saved, you can hit Command S if you're on Mac, Control S if you're Windows or Linux. You can hit that button here, and you can go File. Basically you can just hit here or Control S. So if I do that, you can see here, it will be very quick. Yeah, checkpoint created at, and normally it's the error at the time. So it just means that it has been saved, your notebook has been saved. If you go back in the tab here, you can see that you have a notebook which is currently running. So that means that there is an underlying kernel which is somewhere running that notebook here. So here it's green to say that it's running. Here you have running to explain that there is a kernel running currently that workshop. The thing, if you close directly, don't do it, but if you close the tab here, we close the notebook but won't close the kernel, so it won't be very clean, because there will be on your computer currently a Python process which is currently running a notebook which is not open. So I do not close properly. So it's what I've explained here. If you want to close properly a notebook, to close the notebook itself and the underlying kernel, you need to do it like File, Close and Hold, and you close the two things. It will be very clean to do it like that. Close and hold. And here you can remark that the icon is no longer green, there is no longer running, meaning that there is no kernel running that notebook. If you click once again, it will open once again the notebook. Be very careful when you reopen the notebook. Here you see input 1, you have some text, you have some display, so you're under the impression that the kernel, the underlying kernel, already know what is X and know already what is Y, etc. That is a lie. That is something is not true. The underlying kernel had just been opened. It's just a it's just a fresh new notebook. Nothing has been run for now, and it's a good thing when you open a new notebook. Just sure to hit kernel. It's cell run all, and so it will run all the cell one after the other. If I do that, you can see that it begins once again at 1. Okay, be really careful about that. You can see plenty example of cool notebooks. So here you have some examples. There is a very amazing thing they can do with it. There's some people make some widgets, or like you have a cursor, you can change things. They will change something in the plot, things with the sound analysis or figures. Very amazing stuff for both data analysis, to present your work, or for teaching. So it's a very good tool, very with a lot of possible extensions to it, and you can see plenty of examples on the website if you're interested in. I won't go too much into the detail. You have a rough idea of what a notebook can do, and hopefully it will be very useful to you, even if you don't continue machine learning, I hope. Okay, so then we'll continue with important libraries for machine learning. Okay, so let's continue with important libraries with machine learning. So I'm going to explain plenty of different libraries that might be useful, that are useful when we do machine learning. So I give you some of them here. Here you have so we'll use 3 of them: NumPy, Matplotlib, and scikit-learn. NumPy is a library that implements the kind of the notion that you can imagine, the notion of vector into Python. So rather having lists, we'll have what we call arrays that can to represent the notion of vectors. So it's a very useful library. You have Matplotlib that is used to plot graphs, since we love to plot graphs as scientists. it will allow us to do that very easily. You have scikit-learn, which is the library dedicated for machine learning that we will use a lot in that workshop. But just to, so it will be the three libraries that we will use in that workshop. Just to mention two other libraries, which are pandas and scipy. Scipy is a kind of collection of plenty of well-known algorithms that might be useful if you need like optimization algorithm or fast Fourier transform or whatever. You will find them into scipy. There is all the classical algorithm written with for Python and a very efficient way. Pandas is a library that is dealing with structured data. So if you have a CSV file, experiment 1, experiment 2, experiment 3 with columns and things like that, then you can try to use pandas. It would be more efficient. So Python, sorry, NumPy. So sorry, I try to put the figure in such a way that you can still see things. Okay, so NumPy, the motivation. In standard Python, the data collection objects are lists. So there's plenty of advantages. The list can contain different types of objects. You can concatenate like in lists like string with numbers with whatever. It has an easy insertion. You just need to use the method called insert, and you want to insert things. In easy concatenation, you can glue, like what I call concatenation is the glue together two lists together very easily just using the plus sign. There's plenty of disadvantages, especially if you are in a scientific context. Like the sum of two lists is concatenation, and since we tend to represent our data collection in scientists are often represented under the notion of vector. It can be cool to have the notion of when you add two vectors together, you want just to have a term-by-term addition. So that lists do not allow you to do it directly. If you use the plus sign, it does the concatenation. It is very slow for very large lists. If you want to deal with two lists and you want to add term by term and you make a for loop for that, it will take a while. And it has no usual function that we tend to use all the time that we tend to use all the time as scientists, like the mean of a vector, the sum of all its terms, the variance, the maximum, etc. So we scientists would like to have an object represented in Python that tends to represent the notion of vector, right? So the solution for that is NumPy arrays. So in fact, NumPy is pretty much defining only one big object, which is arrays, and plenty of method and operation that you can do with it. So in fact, NumPy is so important because it defines the very notion that is usually used in for scientific application, that all the other libraries like Matplotlib, they will use scikit-learn, in fact use NumPy arrays. So each time you want to install Matplotlib, it will install NumPy by default because it uses it as a common ground, and all the other are using the same. Okay, so it's good to know what is NumPy array. So in order to import NumPy, what you just need to do, so NumPy does not come together with Python by default, but since you install Anaconda, it has installed NumPy alongside with it. Okay, so how do we import NumPy? So it's a library, so you just need to use import NumPy very easily. Okay, and here it's opening, it's importing NumPy. Okay, so here we are going to create two objects, A and B. A is going to be a very classical list, a classical Python list, and B is going to be an array, and we'll see the difference between the two. So A is equals of a list 1, 2, 3, 4, 5, be sure to have, each time I define a list in the following slides, just be sure to have the same length for all the, each time I define an array in the next slide, be sure to have the same length for all the arrays, because we're going to make term-by-term addition. So here I'm defining a list for now for 5 elements, and here I'm defining an NumPy array. So NumPy.array, so that's the name of the library, .array, which is the object I want to create, and I'm going to create an array. Let's just say, you can imagine an array just to be like a vector for now, and it's going to have as element 1, 2, 3, 4, 5. So I'm creating 5 elements. Be sure to use 5 elements. You can put other numbers if you want here, but just be sure that the size is the same. And I'm going to print the type of B. Okay. Shift return. So the first one, A, is going to be a list. The second one is going to be a NumPy.nd array. So it's an array object. Okay. Since we are going to create a whole bunch of array all of the time, and that programmers are very lazy people usually, they tend not to write NumPy.array at each time. So they came up with a kind of nickname for NumPy. It's very common. If you go on the internet and search for information about NumPy, you will find that this nickname is used a lot of times. So rather than using NumPy, they use NP. And the way to tell to Python, I'm going to replace the name NumPy as being NP, is just straightforward. Import NumPy. And here you can put as, and you can put whatever nickname you want, and it's very common to use NP for NumPy. Okay. And I'm going to create another NumPy array, but here I use the nickname NP rather than NumPy. So it does exactly the same thing, as you will see in a moment. So here I'm creating another array with also 5 elements, sorry. So be sure to have 5 elements here if you put 5 elements in B, because in the next slide it will be useful. Otherwise you might have an error. I'm going to print the type of C, and here you can see that B and C are exactly the same type. Have exactly the same type. They are both NumPy array. Okay. So this way of writing NumPy, I will use it in all my slides, so be sure to import NumPy as NP. It's very common to use that kind of things. Okay, so let's see what's happening if you add 2 lists together or 2 arrays. So here I'm going to add 2 lists, A and A together. So I'm going to print A plus A, and after that I'm going to print B plus C. In the slides I won't put the string at the beginning here because it's long to write, but you understand what this is. So here I'm going to add, in the first line I will add 2 lists together, and here I will add an array plus an array. So here the list, when I add 2 lists together, it has just concatenate. So A here was 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it just concatenates the 2 lists together. Here, oh yeah, spelling mistake, it should be 2 here, but whatever, change anything. Here I add two array together, so it add term by term. So here I have B, the first element of B was 1, the first element of C was 5, it added together, it gives me 6 here. The second element is 2 plus 4, it's 6, 3 plus 3 is 6, 4 plus 3, so here I should put a 2, if it was like the slides, it would have been 6, but here it's 7, and 5 plus 1 is 6. If you did define 2 arrays with different lengths, so if for example if I put just 4 elements here, it will have thrown me an error because you cannot add together 2 arrays which are not of the same length. Okay? Okay, so let's continue. You can make plenty of operation with the arrays. So here I'm going like to print, I will do some of them, not all of them. B plus a number. So B is an array, I'm going to add a number. In fact what it does, it adds to each element of B the number here 7.1. Okay, So 2, that was the original array. 1 plus 7.1, it's 8.1. 2 here plus 7.1, it's 9.1, etc. So it adds term by term. I can do the same with the multiplication. So if I multiply by 2.5, it would multiply term by term. So 1 will be multiplied here. 1, the first element will be multiplied by 2.1. 2 will be multiplied by 2.5, sorry, etc. The same for division, the same for power. So here the example like the power. So if I do b to the power of 3, it will each term that will be put to the power of 3. Another one, so that is with a number. So if you make an operation with only a number shown on an array with a number, it will do it term by term with the number, corresponding number. If you do it like multiplication array times an array, so it's no longer an array times a number, but an array times an array, it will do it term by term, and the two arrays needs to be the same length, otherwise it won't work. So here I have an example. So I will do b multiplied by c here. So you notice that here the same result because c made a typo here, but you get the idea. I multiply 1 by 5, so it was the first element of c was 5, and the first element of b was 1, so it was 5, etc., etc., etc. You can divide, do the same thing with the division here, or you can make a more fancy operation. So I remind you that the percentage is the modulo. If you make an Euclidean division, you like, for example, in 5 divided by 1, there is, no, it's the other way around. Yeah, in 5, in 1 divided by 5 becomes 0 plus 1. So things like that, okay? I'll give you this result. Okay, so you get the idea. If it's an operation with a number, then you make the operation term by term with that number. If it's an operation between two arrays, then the two arrays needs to be the same length, and we'll do term by term operation. Very straightforward operation. Okay, you have some very common functions like exponential, sinus, and cosinus. So it's very straightforward. You use np.exp, which is exponential of b, would be like the exponential of b. You can use the sinus, the cosinus, etc. How to access elements of an array. So you have an array, you want to access to the first element, to the second. It's exactly the same thing as for the list in a usual Python. I remind you that you begin to come from 0, so if you want the first element of the list is the one at index 0, and it's used like that. So b, square bracket, the square bracket indicates that I want to access an element from the array, and if I want to access the first element of the array, then I use b, square bracket 0, because it's index 0, b1. I do the same thing for the one at index 1 here, it's 2. If I want to access the last element, I remind you that in Python you have a way to do that very useful, which is just a negative number. So if I want to access the element at index -1, it will be the last element of the list. Okay. So if you want, you can use what we call slices. So it's with the colon sign here. If you want to access, you can put the beginning and the end and invert the steps. So the index at the beginning, the index at the end without including it, and a step. If you do not specify like the step, it will be a step of 1. If you don't specify the beginning, it will be if you don't specify the end, then it will go until the end. If you do not specify the beginning, then it will go from the beginning. So here I'm asking to Python to give me all the number from the beginning up to the end. So in fact, it will give me back b. Maybe you can find that to be weird with syntax. I just didn't put just b, but you'll see in a moment when we use two-dimensional array that this notation, which is in single column, can be useful. Here and here I put another example when I go from the first element up to the fourth element without including it at step 1. So it will be the one at index 1, so 2, 3, 4, and 5 is the element 5 is at index 4, and does not include the one at index 4, but you follow me. And the last example is from the beginning, so here I put 0, I could have put nothing, up to the last element without including it, remember, and with step 2. So that is from the beginning up to the end, so the original array was up to 5 here, so for example you can look at this one up to the last one without including it at step 2. For this, the first element, then this one, and I do not include this one. Okay. So NumPys are objects in Python. So in objects, maybe you have just slightly mentioned it in Introduction to Python, but objects are pretty much everything in Python, like lists. Lists are a good example of object, and they have some something that characterize that object, which are attributes and method. Attributes are some properties, you can say it, that have the object. So in the case of arrays, you can be interested in the shape. Is it one column array with 5 elements, or it is a 2-dimensional array? Things like that. What is the number of dimensions on an array, etc. Methods are more action that you want to do on the array. So you have one array and you want to have like the sum of all the elements. So here is an example, b.shape, so to be the shape. That's a weird syntax. It's what we call a tuple with ground parentheses, and if you see at least one comma inside is what we call a tuple. You can see it just being as, for now, just to be it at a list with only one element, 5. So that means since there's one element into the shape, it means that it's one-dimensional, and you have the first element here is 5. It means that in that dimension it has 5 elements. We'll see in a moment 2-dimensional array to see how shape will behave in that case. Then you can use another, which is a method. You can use sum. It will sum all the elements of an array. So here it's really an action. Since an action is a kind of function, so if the syntax is b dot the name of the method, around parentheses, and you can put the attribute if there is here, the argument, sorry. You can put the argument inside. If there is no argument, just put nothing, but just put the round brackets because this is a function. So here it will sum up all the elements, 1 plus 2 plus 3 plus 4 plus 5, and give my 15. Okay? So how do we know the attributes and the method? It's very easy. You can go on the the internet, just NumPy array attributes. Oh, sorry, I will put it just here so you can better see. NumPy array attributes. Here, you go to this link here. So it's the manual of NumPy, and you see NumPy 1.15 manual, and there is array attributes. So you have plenty of attributes here. You can see that there is the shape I've just used. You have all the ones. You have here others, and you have the methods, which can be very useful. So here the array conversion, shape manipulation, item selection and manipulation. So we have plenty of them, and yeah, can be very useful. So yeah, and here you have the most common one, which is, for example, I think sum is just here. So the one we use for sum. So we can have a look at them. In the array method, if you want to do something very simple on your array, you want to know what is the maximum, what is the minimum, what is the position of the maximum, what the index of the position of the minimum. If you want to, I don't know, you will use Ravel at some point. It's just to, if you have 2-dimensional array, to transform it to 1-dimensional array. If you want to know standard deviation, if you want to sort it, if you want to search an element in the list, if you want to make all the product of the terms, if you want to know the variance, if you want to know
the cumulative sum. Yeah, pretty much everything which is simple that you can imagine, it has a good chance to be around that method. So please have a look at it if you need it. Okay, so let's go back in our notebook here, and let's create array. So I'll show you a way to create array, which is using np.array and put like a list of all the elements. There's other ways to create directly arrays, and for that you use functions of NumPy. So you have arrange, which is from NumPy. So arrange is for array range. It works exactly the same as for range in standard Python. Range gives you back a kind of list from all the elements between the beginning up to the end with a certain step. So it's the same syntax here. Here you put the first element, here you put the last element, and here you can put the step. And contrary to range, you can put a float step. In the standard range in Python, you need to use integer. Here you can put a step which is not an integer. So if you do that, you have all the elements from 1 up to 5 without including it. I remind you that the last element is not included, and at the step 0.5. There is another way to do kind of the same kind of things, which is linear space here. Yes, a tip for Jupyter I haven't told you is auto-completion. So if you begin to write something, you can use the tab key. So the tab key is this one here, and it tries to autocomplete. So here I begin to write np.lin and hit the tab key, and so basically it tried to guess what it was. So it proposed me two things: lin alg or lin space, and I'm going to use lin space. I put the beginning. I want element from 0 up to 10, and here rather than putting the step, I will put the number of subdivisions. So I want 4 subdivisions. Be careful, I don't know, just to mention, lin space is the only example I know where you would try to have all elements from the beginning up to the end, where the end is by default included. You can not include with a certain option in lin space, but by default is included. So here if I hit that, it will be all the elements from 0 up to 10 with 4 subdivisions in total. You have two other functions which are very straightforward. If you want to create an array that contains only one, a whole bunch of ones, then you use np.once, and here you put the size. So here I want an array with 5 elements with ones, and you can do the same thing for zeros. So here. Okay, that's straightforward. Okay. 2-dimensional array or even higher dimensional array. So let's create an array with 2 dimensions. So let's do it the old way. So here I'm going to create an array, and I'm going to create it with a list of lists, and each list will contain 4 elements. 1, 2, 3, 4. Here the second list will be 10, 20, 30, 40, and the last list will be 100, 200, 300, 400. So just a slight thing here. I'm going, since I can put it on one line. In Python, if you open the bracket, your round bracket, you haven't closed it in the next line, then you go automatically to the next line and try to find where there would be a closing bracket. It allows you to write that on several lines. So this indentation here won't be interpreted as an indentation like for the definition after the definition of an option of a function or for loop or whatever. It would just open it and continue as if it was in the same line here. Okay, so I'm created this guy here. So I'm going then to print A. So you can see that it's a two-dimensional array. Each rows correspond to each of the lists I've defined, and each column corresponds to, it would like that. Okay. If you want to look at the shape, I don't know if you remember, but with our previous example, one-dimensional array here, B just the shape of B was just you can imagine that it's been the list with only one element, and here if you hit the shape, it will have two elements, 3 and 4, meaning that there is 3 rows and 4 columns. Okay. If you want to know the number of dimensions, so here you have the number of dimensions directly because there has 2 elements, but there is another way to access to that information with the attribute ndim. You can even have higher dimensions, like having like a 3-dimension array. I won't too much mention it because we have mainly used just 1-dimensional arrays or 2-dimensional array. Okay. So how to access elements into an array, into a multi-dimensional array? So here I have my first array here, and I want to access the element at position, a row at index 1 and column at index 2. I remind you that we begin to count from index 0. So A, I'm going to print it. Print. So A, I want the one at index 1, then I use the index 1 and comma 2. Okay, so that will be the element at row at index 1, so it's this row here, and column at index 2, so it will be this guy here because I'm beginning to count from 0. 30, right? Okay. If I want to select all lines, so what I can do, I want to select all the line at index 2, I can use that. So here I ask row number 2 at index 2, so it will be this one, and I want all the columns from the beginning up to the end. So here the single column sign makes sense, right? So I do that, I will have the second column, and I can do the same thing, the second row, and if I want to have like the first column, then I use the same. Here it means that I want all the rows and the one at index 1, and give me back an array with just the column at index 1. Okay. Okay. We can use logical conditions. So, as I used for the one-dimensional vectors before with operation, you can do the same with arrays, and you can even use an operation what we call a comparison. So you want to compare all the elements of my two-dimensional array A compared with the number 25 and look at when it's higher than 25. So if I do A is higher than 25, it gives me back a two-dimensional array that contains what we call booleans, true and false. And here, if you look at the element which is here for A, indeed is smaller than 25, so it's false, it's false, it's false, it's false, until this element here is the first one at which 25 is, the element of A is higher than 25. So here it begins to be true. Something that will be very useful for us, if you want to access to all the elements of A of an array, from which you want to have all the elements of A from which A is higher than 25, for example. So you can use square brackets, and usually here you put indexes or slices, but you can also put arrays of of booleans. And since A higher than 25 is an array of booleans, it's just the one I had before, it will select all the elements for which this array is true. So it won't select this element, neither this one, etc., but just select this one, etc. So here, oops, sorry, I put a new here. If I do that, then I have all the elements of A from which you have, which are higher than 25. Okay, so you understand this syntax. Rather than putting an index here, I put an array of booleans, and we'll select the one for which it's true. And a higher than 25 is an array booleans with true and false, and only select the one for which a is higher than 25. Okay. There's something that is important, I think, to mention here. So let's imagine I create the array B here. So B, I'll remind you what it is. It's just an array 1, 2, 3, 4, 5. B dot shape is 5. So it means it's a one-dimensional array with 5 rows. For Python, even if for us it would be the same object, for Python it would be different from a two-dimensional array with 5 rows and 1 column. I'm going to make the example here. So I'm going to define like the array D, which is going to be the same thing as B, but I will use the method reshape. So I just change the shape of the element B, and it will be 5 column 1. So here I'm creating an object which is exactly the same thing as B. It just has a different shape with 5 column and 5 rows and 1 column. Okay. So if I print D, it will be something like that, and D dot shape is 5 columns and 5 rows, sorry, and 1 column. And B is not the same thing as D. For Python, it's 2 different objects. If you want to go from one to the other, then you need to use something like dot reshape. It will have some importance for scikit-learn that scikit-learn most of the time always accept 2-dimensional arrays and not 1-dimensional array. So sometimes we'll use that trick here. So please remember that. Okay, so now we continue with matplotlib. So matplotlib is a library used to create graphs, because as scientists we very like to do graphs. So here you have an example. It's the kind of thing that you can do with matplotlib. It's quite a powerful tool with very few lines. You can do pretty nice pictures, pretty nice figures. I meant. It's a very nice one. So let's do it. Let's have the example. So matplotlib is very large libraries where you can do very complicated things with plenty of complicated objects. Here we're just going to use a sub-libraries of matplotlib called pyplot. And as usual, since we are very lazy people as programmers, we are going to use a nickname. The same thing that we did for NumPy as NP. Here we'll use matplotlib.pyplot. So pyplot here is a sub-library of matplotlib, and we'll use it as PLT. So import matplotlib as dot pyplot as PLT. Okay. And I'm just going to create a very simple array, which is just np.array. And here I'm going to use 0, 10, 3, 4, 2. Okay. And I'm going to plot that array, plt.plot y, very simple. And at the end, you need to put plt.show. And here it plotted directly. So if you don't put the dot show at the end, maybe depending on the configuration of your notebook, it will print it. It will still display it. Sometimes it does not display it by default. So be sure to have it so that to put it so that if you send the file to somebody else in the book or somebody else, when the person hits that command line, it will display the figure. Okay, just a side note here. Sometimes you see import example on the internet. You'll see import pylab as PL. You can do exactly the same thing. Then rather than using PL, you use PLT or the other way around. It's exactly the same thing. I do not know why they created two objects that represent exactly the same thing. It tends to be on the internet much more common to use matplotlib.pyplot as PLT, but you might find some example with PL. Just remove the import pylab as PL and replace it by import matplotlib.pyplot as PLT, and normally it should be exactly the same thing. So rather than explaining to you how to use matplotlib in very high details, I'm just going to plot that graph here. And just to show you that in very few lines you can plot a graph which is very nice looking. I won't be ashamed to put that kind of graph, at least the look of the graph, in my own papers. So let's do it, right? Let's create this graph very easily. I will do it step by step. So the first lines here are just to define what we're going to plot. So I'm going to define the x-axis. That is going to be an arrange up to 15. So it will be all the number from 0 up to 15 without including 15. I'm going to create the first y-array, which will be the sinus of 0.5 times x, and the other one will be the cosinus of the same thing. Okay, so I'm going to plot those two things. plt.plots. So here the syntax is you put the x-axis and then the y-axis, x, y, 1. Okay, so I will do it step by step. So here I'm going just to put those two, plt.show. So let's see what's happening just writing that down. Okay, so basically it plots the two figures, the two lines with different colors, etc. Okay, so it looks a little bit from what we want, but here we want like dots. For the first one we want dots and dashed lines. So the way we do that here, we use some kind of very small syntax. Since I want big dots, I will use a O, a small O. It's not a 0, it's a O. And I want to have dashed lines, so I use 2 dashes. Okay. And for the second one, it will be the same thing. It's just that rather than having dots, we want square. So we use S like square and still dash line. So let's see what's happening. Okay, cool. So it's doing the thing that we wanted. Okay, but I want those marker here to be a little bit larger. Here they're quite small, they are not that visible. So we can use with marker size equals to 10 and do the same thing as here. Okay. So to increase the marker size, the line width, I want to have line width a little bit larger for both. Line width. So with the line of the width of the line of the dash line here, 1.2. Okay, so it's a little bit thinner than the one by default. Here I want to change the color. I don't want the color to be orange and blue. I want the color here for this one to be red. So I use R for red. So R will be for reds, O will be for orange, B will be for blue, Y will be for yellow, and for black it will be K, because B is already used for blue. So you use K if you want to use the black. Okay, so yes, I remind you here, I opened that parenthesis here, I haven't closed in that line, so I'll go to the next line as if it was in the same line. Okay, and I do the same here, and here I want to be in black, so I use K. Okay, this is that. Okay, that's a good color. Let's continue. So we want to create that this legend here. So for that, you need to specify in each of the plots which label it corresponds to. So here label will be sine for the first one, and the label will be cosine. If you do that and just do that, it won't change anything. So you need to plot the legend. So this line here, plt.legend. Okay, so here let's imagine I want to remove the frame around the legend. So usually there's an option for that. Frame on equals to examples. Okay, you want to put some y and y label and x label. So to do that, you use y and x label, plt.x label, time in seconds, and plt.y label will be fluorescence in arbitrary units. So maybe you cannot see it very clearly. I'm just going to do something just for me, for you to better see on the screen. I'm just going to increase the default font size. Something like that. So if I do that here, yeah, you better see here, it's bigger. Okay, and if you want to change like the ticks, so here, okay, the ticks are from the default one are the same here, but if you want to change it, so rather than having -1, -0.50, 0.51, just have -1, 0, and 1, for instance. How you do that? You use plt.yticks, and here you can specify the one you want. So I just want -1, 0, and 1. So -1, 0, and 1. Plenty of other things, okay? So you see in very few lines, so that the only lines that are dedicated for the plotting, you can have a very nice result already, right? Forget about this one here. Okay. So if you want to continue in Matplotlib, oh yeah, sorry, before I continue, if you want to save the figure, you can use, rather than putting the save fig, you can rather than putting the plt.show, you replace that by type layout and save fig. Be sure to remove the show, otherwise it might make something wrong. So what is type layout for? It's kind of, I don't really know why it does not do it by default. It's just when you create the figures, sometimes it tends to plot things like which are outside from the first crop it made for the figure. So like when you add a label, maybe a little bit lower than the one expected. So you need to say to Matplotlib, I'm going to be sure that you in your crop you contain all the figure altogether. Okay, so it's what we use type layout here. It's kind of annoying to use it at the all time, but yeah, this is the way they are. And here you just put the path to your file if you want to save it in the same directory as same directory as the one where there is your notebook. You can just use put the name of the file, png. It tries to guess the format from the extension, or you can specify the format. You can specify plenty of things like the number of dot per inches, etc. I'm going to use that. Okay, it does that. And here you go in my documents. There is a new file which has been created in the same folder as my notebook, which is currently running. Click it. It's the one you want. Okay. So if you want to continue with Matplotlib, there is pretty much two solutions. Either you download the PDF with the documentation, just like that, you print it and you read it before going to sleep. That's one possibility. Or you can do the way that everybody else is doing it. So the way that everybody else is doing it, including myself, the way I learned about, sorry, come back here. The way I learn about Matplotlib is always the same kind of things with the internet. I use matplotlib gallery here, and I go to the thumbnail gallery of Matplotlib. I go here. I have plenty of examples here to do more complicated stuff that we did. And you can just go click on one of them, for example this one, and pretty much you can just copy paste this code into your own notebook, for instance, and change slightly things to adapt it to your example, right? So it's very easy and can learn plenty of things with that. So be sure to use that more convenient way. Otherwise, you can also ask questions about Matplotlib on Stack Overflow or of the website where they can answer your question about programming. Okay. Okay, so let's continue with another view of the machine learning.
Okay, so let's continue. So about machine learning. So there is several types of machine learning. For example, you have supervised learning. Supervised learning when you have a whole bunch of data and you have an answer to those data. So the classical example, you have like pictures of cells, and some specialists came and annotate each of the cell, saying, okay, this one is cancer cell, this one is not cancer cell. And you are going to learn about those data in order to make a model that can predict from a new cell that you haven't never encountered before, if it is a cancer cell or a benign cell. So there's there's two possible supervised learning algorithm. There is classification and regression. I will talk more in details about those in the following slides. Otherwise, you have the unsupervised learning here. Rather than here, it's more like have a whole bunch of data, and you ask to the computer, find some structure into it. Do you find things that are interesting, some structure, things like that? Can you group things together, things like that? So it's the unsupervised learning, and of course you have everything in between semi-supervised learning, things like that. In this workshop, I'll mainly talk about supervised learning in details about classification and regression. I will have a small talk about some unsupervised learning algorithm in the third day. Okay? So here, sorry. Up. Swing-cam is here. Okay. So supervised learning. So as I told you, the idea of supervised learning, you have a training data set which is annotating. You built your model, so really you're doing that. The computer is building itself while reading the data, and then you have ready to use model. Okay, cool. And it can be subdivided into two kinds of algorithm. You can have the classification or the regression. The classification is like a yes or no answer. So is it a cancer cell or is it a benign cell? So it's yes or no. The idea is the classification. Regression is more continuous answer. So typically you have the length and the width of the cell, and you want to deduce the volume. The volume is a number, so it's more continuous answer rather than having a yes or no answer. So the idea of so here's the classification in detail. You have a whole bunch of data, you are learning, you are making your model, and when you have built your classifier, it's ready to use for new data, like data never seen before. So you have a new cell and you want to classify it to be a new benign cell or cancer cell. So that's the idea of the supervised learning, to build the model on known examples and then to use it for new examples that you've never seen before. So regression is the same idea, but here is a continuous answer, as I told you. Okay, a little bit of vocabulary. What is targets? What is features? So features is all the things that you, I will begin with the targets. The target is the thing that you want to identify. It's the classification example. Then it will be like, like, is it a cancer or normal cell? If it's a regression, then it will be something like, what is the volume that you want to estimate. The features is all the data that you can have in order to guess the target. So it will be what is the shape of the cell, what is the nucleus diameter, what is the boundary smoothness, what is the length, things like that. So that's will be the information that will be available for your classifier in order to make a prediction for the targets. Okay. Something which is very, very, very important. It's how can we validate our model, and it's the main. I mean, if you have a take-home message about this workshop, it will be the one in the following slides. So let's take the example of a regression. It will be exactly the same problem about classification. You need to make you need to do a regression with those data here. So you can imagine here it's very easy because you have just one feature that needs one-dimensional feature. Usually we'll have much more dimension for the feature, but here in this simple example, just take one-dimension feature. And so you can imagine that a solution like that seems, as you see it with your own eyes, quite satisfactory, right? It seems to follow pretty much the data. It seems cool. But the computer does not know if it's a good answer or not. You will have to have some way of telling it that it's the optimal solution that you want. Because the computer can say, oh, maybe I can propose that. I will try to make just a linear regression with just 1 degree polynomial, and we'll do something like that. When you see that, you as human, you intuitively see that maybe you don't take too much advantage of the data, right? Something is missing. So maybe the idea would be to increase the complexity of your model. Here your model is very simple, and when you are dealing with regression, one way to increase the complexity of your model is just to increase the degree of the polynomial, right? So let's increase the degree of the polynomial and just take a 20-degree polynomial. So here the computer has got a model that is go through each of the data very precisely, and all the data you give. You as human, when you see that, you see, yeah, maybe I'm taking too much advantage of the data. Maybe it's the other way around. Maybe I'm doing too much of it. It's what we call overfitting. You are too close to the data you have given to the computer. Sorry, I forgot to say that is underfitted. This problem is underfitting, and the second one is overfitting. Okay. So how to avoid underfitting, or even more, or even more difficult, the overfitting? So the main idea, the main core of it is to keep some data that you haven't used to build your model in order to make a model validation. Because if you put new data, like the red dots here, which are data that you keep apart, and you try to compare the performance of the model on those new data, you can see that this model will behave very badly compared to this one. Okay, so that's the main idea to avoid overfitting, is to keep some data apart when you have it, just to make the model validation. And you build your model on the training data set rather than a testing data set. Okay. So yes, that's just a summary. You have two kinds of problems that you need to avoid, is underfitting or overfitting. If you have underfitting, then you need to increase the complexity of the model. And if you are overfitting, I will show you some methods to avoid overfitting. So the final test will be the model validation with the data set that you put apart at the beginning. But there's other ways to avoid overfitting, just by checking at the very end. I will talk about like cross-validation and things like that. Okay? So how is organized the pipeline of the machine learning? So usually it works like that. You have a collection of data, you take some pictures, you do things like that. Then you treat those data in order to extract some features. So if I take the example of the cell, you take pictures of microscopic pictures of the cell, and then you want to treat the data in order to select what is to select in the image what is the cell, what is its length, what is its width, to do it automatically. Then you have the model construction. You said, oh, okay, from those features I want to construct a model like that, taking those features into account, and I try to build it. And at the very end you have the model validation. So yeah, that's basically as I explained to you. Here you have the collection of data. I won't talk that much. I won't talk, in fact, at all about this procedure here. If you are interested in that procedure, maybe you can have a look at the workshop 21, digital imaging processing with Python. Yeah. So basically, it will be that. I will more concentrate on those two parts: model construction and model validation. Okay. So let's take an example of a classifier. We'll begin right away. I won't go, as you see in this workshop, too much into the mathematical detail. I will rather give you an idea of what the algorithm is broadly doing, give you the intuition of what the algorithm is doing. The goal is not to make you implement these algorithms, but rather to use them as they are already implemented in scikit-learn, and then know a little bit the drawbacks and the advantage of each of them, trying to broadly know what they are doing. And I think it really should be good enough for you. If you want more details, then of course you can search a little bit more, but I think that at first intention it could be a good thing to know broadly how they are doing. So this is what I will do here by giving you the first algorithm, and I will broadly explain. I will explain to you intuitively what the algorithm is doing. So the first classifier you see is a decision tree. You see this is a very simple algorithm. Is not that efficient in itself, but at a second step you see why it would be useful. So let's imagine like you have a two-dimensional array here. You have some brown green circle and blue dots. So that's the first feature, and that's the second feature, and the target is to predict if it's a square or a circle, a blue square or round a green circle. And yeah, you want to build a model. So we'll use a decision tree for that, and broadly speaking, how the decision tree is doing is like that. You first select a feature for random, at random, for instance, and then you select a threshold that separates the most the data from each class. Of course, all the math of the algorithm is hidden behind the word "the most." We will do it intuitively. Of course, the computer, the algorithm itself is built with a real definition of what it means by the most. If we want the details, it includes the Gini index. It tries to maximize the Gini index, and the Gini index tends to separate the two. If you are not familiar with that, or you are not interested in that, just try to have a rough idea of intuitive idea of what is the most. When I say separate the most, and you repeat those two steps until a satisfactory model is achieved, with some stopping condition that will define yourself. Okay, that's a simplification, of course, of the real decision tree that we will use, but I think it's intuitive enough, and you'll see what they are doing. So let's make an example. So I begin with this data here, and I just select one features randomly, and let's just take x1, for instance, and then I choose a threshold. So do I say that separates the most the two data sets? Yes or no? Let's just say maybe this one will be better. So if it's above 5, you'll do something. It's below 5, you'll do something else. Okay. So let's imagine you are in that spot. We are below 5, so we are here, and we try to find another threshold, but this time for the second index, which is the second features, which is like x2 here. Okay, so we select it, and we found that the best, the one that separates the most the two data sets will be this one, and do the same thing on the other side. So this threshold here is on this one. So here you have built a tree, and you can fill it. So if you are below 5 for the x1 and below 3 for x2, so you are here and here, it will be circle. if you're below 5 and higher than 3, then it will be squares, exactly. What do we call that a tree? Yes, if you flip what you just built upside down, you find a tree, and so the vocabulary tends to be that. That is intuitively the root, and that is the leaf, even if it's downside. And something will be interesting is the tree depth. How many steps do you have until reaching the leaves, right? Okay, so what I propose to you is to create your own tree. So it makes more sense when I'm in class with plenty of students, because it's a three-dimension data set. It's three-featured data set, x1, x2, x3. And to each of the students, I give them sheets like this one here. Here I give them sheets of paper like this one, but as you can see, you don't have the same projection. So here it will be x1 and x3, and this one will be x1, x2. So each of the students are have different projection, and I ask, but it's the same data set still, and I ask them to build themselves a decision tree the same way we just did before. And yeah, so what I propose to you who are doing this workshop while watching the video, I propose you just take, here I go, yeah, I know. Okay, so you can choose either one of the three figures here, so it's the three possible projections. You can choose one, the one you want, and just build the decision tree. So you can hit pause in order to do it. So you do it exactly the same way as we did before. So you choose one feature, you choose one threshold. It's if it's above or below, you can choose that, or you can and then after you take another features and do that. Of course, every one of you will have a different tree, and that's perfectly normal, and your tree won't be optimal for sure, but as you see in an instant, it won't be that much a problem. So I propose you just to pause, just choose one of the three, the one you want, and fill out the tree on a piece of paper, and just start the video again just after that. Okay, so I assume that you take time to fill this tree, right? And let's see what we will do with that. So when I'm in class, everyone has built their own tree, so their own personal tree, which might be different from everybody, and on different projections. And what I do after that is that I ask the collective answer of people. So so in fact, what I have built in class with plenty of students trying to make their own tree on their own personal projection, is what I built is in fact a random forest. And random forest is composed of many decision trees that are being made completely independently. So maybe you can imagine, you can say, and you're right, that this decision tree seems to be a very bad classifier, a very bad object, because it's kind of silly, it's too simple to make complicated classification. But in fact, yes, you're right, each tree is completely stupid, but the collective answer to all the trees will tend to give a better answer and will be much more robust to the overfitting. Okay, so basically when I'm in class, I go here and I ask them the question, what is your answer if x1 is equals to 0, x2 is equals to 2, and x3 is equals to 0? What is the answer? And I'm asked to the people to vote, and they all vote saying if they think it's a wrong blue circle or square, a red square, and ask them to vote, and I take the majority vote, and I say that will be the answer that will give the random forest. Okay, so you have the decision tree, and a collection of decision tree, and the majority votes will give you a random forest. In fact, random forests are very good classifier. If you have one classifier to try out of the box, it will be good to try with a random forest that give pretty much good results. Okay. Okay, that's cool. So in order to do that, either you can take plenty of undergraduates and make them all of them make their own decision tree on the projection or of your data, or you can ask scikit-learn to do it for you. So it's what we'll do in the following. So we just make a small introduction to scikit-learn. Okay. So let's go back. So scikit-learn as NumPy, as Matplotlib, as Jupyter is not by default in Python. You need to install it, but since you install Anaconda, which is a distribution with plenty of libraries, of scientific libraries, it will be already available for you. Okay, so how to use scikit-learn? Then you just need to import scikit-learn. Import sklearn. Okay, and just to be sure, if you exit your notebook, be sure to have matplotlib open. .pyplot.splt. And what will we use here is a dataset that is a well-known dataset that is the breast cancer Wisconsin dataset, which is pretty much the example I gave before. You have pictures of cells, and they have determined the width, the shape, the nuclei diameter, things like that, and they annotated them in order to predict if these are cancer cells or benign cells. And in fact, since it's a very well-known dataset, in fact it has its own Wikipedia page, you can go to see it. It's a very well-known, and usually when you build new algorithms of machine learning, you tend to test on already well-known dataset that whose data are freely available. So they are so well-known that in fact they are already built into scikit-learn, so you can access to those data directly using scikit-learn and sub-library of scikit-learn, which is dataset. So we import scikit-learn.datasets that contains all usual datasets, including the breast cancer dataset. And in order to have the cancer dataset, breast cancer, it will be sklearn.dataset.load breast cancer. Okay, so that's a function. You need to load it, and hopefully it will work. Takes a while. Okay. So what is inside bcancer? So if you try to know what kind of object is bcancer, you'll be kind of surprised, because it will be something like called bunch objects. What is it? What is this object? But in fact, this object contains many methods and rather plenty of attributes, including one which is called data, and bcancer.data. So the attribute of bcancer that is called data. What it is? Oh, that is something we know. It's a NumPy array, right? Okay, and you can print, for example, the shape of it. It will be 569 and 30. So it will be a two-dimensional array. You will have 500 kind of rows, and 30 columns. Okay, what does it correspond to? We see in a moment. There is another attribute which is target, and it's also a NumPy array. You can look at it. Oh, so target is a one-dimensional array with 500 rows. Okay, cool. So what does those two rows and column correspond to? In fact, scikit-learn does it always the same way. When you have an array that will represent the features, it will be always the same thing. Each row will represent one sample, okay, and each column will represent one feature. So here what it says is you have 500 and so rows. It means you have 500 samples, and 30 columns
that correspond to each column will correspond to one feature. So for example, the first feature would be something like the length of the cell, the second feature would be the shape, etc., etc. And the target has 500 rows because it will be just a yes or no answer. Let's have a look at it. I think, yeah. Of course, each sample, the first row here corresponds to the first row here. So from those features correspond that target. From those features here correspond that target, etc. So let's have a look of what it is. So if you look at data, bcancer.data, and I would just have a look at the first row. So that will be the first row. Okay, it's a whole bunch of numbers. It will be numbers between 30 numbers, each of them corresponding to a feature. How do I know that what features that number corresponding to? I can have a look at, I think it's bcancer.data. Oh, it's names maybe? Features, names, yeah. In fact, it's available here. The first feature here is the mean radius. The second one is the mean texture. The third one is the mean parameter, etc. So it's what I basically say here. The first one is radius, texture, parameter, etc. So again, I can have access to that number, but in fact, it won't be that useful to really know what is corresponding to. You're just going to take that number and use them to build your model. Okay. If you have a look at the targets, then you can have a look at bcancer.target. And it will be a whole bunch of 0 and 1, 0 corresponding to malign cells, and 1 corresponding to benign cells. Okay? How do I know that? It's just that there's another object called target.name, and it tells that the first 0, 1 correspond to malign, and the second one to benign. Okay? Okay, so once we know that, we are going to create our decision tree. So let's create a decision tree from scikit-learn.tree import decision tree classifier. Okay? Okay, so I've imported that, so that's an object I'm going to use. We are going to create an object called bcancer model, which is decision tree classifier. And I'm going to specify what is the maximum depth I want. Max depth. And just put it to be 4. Okay? So what I did here, I just say I'm going to create be ready, scikit-learn, be ready. I'm going to create an object which is going to be a decision tree classifier with the maximum depth 4. Okay? And it's just what I did. I didn't fit them over for now. Here in the next cell here, I'm going to fit it. I'm going to tune. You remember the small robot which is tuning itself, as what I'm doing right now. bcancer model.fit, and I'm going to fit what corresponding to what, the bcancer.data, the features corresponding to the target. Okay, bcancer.data, and we'll feed it bcancer.target. Okay, here it prints some information. It tells me, okay, I fit this model with those information. You can recognize here the max depth. For those who remember, there is the which criterion it used to make the decision tree. It's just a Gini. You have plenty of information if you need. Okay. Okay, so we built a model, you tune it, let's test it. Okay, so how do I do that? We are going to test it on data that we already have. bcancer model.predict. Here I'm going to put some square brackets here, meaning that I'm going to create a small list that contains only one element. I'm going to explain that why. Okay, so, and here bcancer.target. Okay, So here I ask to the computer, what is your prediction from that data? That data is the first row, so it will be the first sample. And what is its prediction with the model? And here I say what was supposed to be the answer. So here I predicted that it was a malign, right? 0 is malign. Yeah, 0 is malign. And I should have predicted that it should be malign. So for this one, it works. Cool. Why do I put a square bracket here? It's because predict want to have plenty of different it can predict plenty of different samples at the same time, and expect it to have a two-dimensional array that contains each row will represent one sample to predict. Okay, and here, since it expected that this particular shape, so it will be like number of the shape of the array should be number of rows times number of features. If I just use this guy here, shape, it will be just 30 rows, so it won't be the one it expects. So in fact, I will do something like, if you want, it will also work if I do that, np.r, I will reshape it to be something 31. Remember, oh, sorry, I forgot reshape, and I forgot some parentheses here. Okay. And this guy here has the correct shape. It will be, what's the seconds? It won't work. No, it's one row, 30 arrays. I think it will work. Okay. So that will be one row and 30 arrays. I think that 30 features, yeah. So basically is what I'm doing here, just quicker with just putting a square bracket here. If we do that, hopefully it will work. So yeah, it will work. So it's why I'm doing with a square bracket here. We see this problem plenty of times. Scikit-learn will expect a two-dimensional array, you just want to pick it for one, and you'll be kind of annoyed with this kind of problem. So I will try to save you some times by putting the square bracket when we need it. Okay, and you might have a problem like saying I do not expect this shape for the predicts, then it means that you did this kind of mistake. So here you predicted for the first sample. Let's do it for the 90th one. Okay, so that's supposed to be a benign cell, and indeed I predicted that it was a benign cell. Cool. Okay, let's predict every one of our samples. So let's see what is the prediction. And here I'm just going to remove this square bracket here. And this guy here so this bcanswer.data do have the good shape. It will have a number of rows and the good number of features. So it will be a two-dimensional array expecting that predict. So it's why I removed the square brackets. And I will say that the prediction is going to be bcanswer underscore prediction. So I remind you, like, I'll go to the line so that you can see. I'll open a parenthesis here. I didn't close in the same line, so I go to the next line as if there was no break of line before. And I'm going to print bcanswer prediction. Okay, whole bunch of zeros in one. That is the prediction for the first row, second row, etc. Let's see if it corresponds to what we should have predicted. So bcanswer prediction, is it equal to bcanswer? Yeah, I write it the other way around. Bcanswer dot target, is it equal to bcanswer prediction? So since I do an operation with two arrays which has the same length, it will be a turn-by-turn comparison and give me back an array containing true and false, corresponding if it's a true target or false prediction. So pretty much everybody is true. You just have one which is false here, for instance. So sometimes you have some false. It's quite rare, but it can happen here. You have another one, you have another one. So sometimes it can be false. So bad prediction. Okay, so let's put a graph around that. Let's do an histogram. Maybe we see better with that. Okay, so here I need to put something
in the new version of Matplotlib, it makes some problem. So in fact, I'm going to transform this array of true and false, this array of booleans. I will transform between to be 0 and 1, 0 corresponding to false and 1 corresponding to true. Otherwise, it won't work when we try to make the histogram. So I'm going to create an object called compare, which is going to be what I just written before. BeConsert.target is equal to BeConsert.prediction. So that will be a Boolean array. And I will type iceType, which is a method that allows you to transform the objects in your array into something else. So I'm going to, for example, break it here. Hopefully it will work. So that guy here is an array of true and false. I will transform it with this method here, iceType int. I will transform it into integer. True will be 1 and false will be 0. Okay. Let's do it. Okay, let's do it right now. plt.hist, like histogram, compare. I will specify the number of beans just to have a nice looking algorithm, nice looking plot, sorry. I'm going to put a white label, which is count, and I will specify the ticks so that rather than having 0 and 1, you will have a nicer ticks. So x ticks, square brackets. So what I say here is that at the position, sorry, I'm going to write it down completely before explaining what. Classified. Actually, it's going to be correct. So that's using one line. Okay, so what I say here, classified. What I say here is that at that position, I'm going to put a label called misclassified, and at that position, I'm going to put a label which is like that. And I'm going to plot it, so plt.show. There it goes. So most of the cells here are correctly classified, and very few percentage is misclassified. If you do the math, you can come up with more than 95% of the samples are properly classified. Cool. So we have a model just with a tree which only has 4 layers and already correctly classified like 94% of the samples. Seems cool. It seems okay. So we already built in a very good object, didn't we? But there's an important question to ask yourself each time you do a model. Are you confident of the results? And what kind of criticism you can do? So make pause here, just for a few seconds, try to think about what we did. And if you for 10 or 20 seconds, try to think about it, and come back when you want to have the answer. Okay, so maybe you saw it, maybe not. The question is, how can we tell we are not overfitting? Maybe we are overfitting. It's not as straightforward as before. The example I gave you before was just one-dimensional feature. Here's the 30-dimensional features. 30 features. It's very hard to plot and to see if you are overfitting or not. So in fact, we did something wrong. We should have, as soon as we had the data, put some apart and use those we put apart at the very end to assess the validation of your model. We should have separated the model into a testing dataset and a training dataset. And we use the training dataset to build our decision tree. And then at the very end, we test with the testing dataset. So in fact, we have no way of knowing if we are overfitting here because we took all the data all together in order to build a model, which is bad. So if you see that in an article, if you see that you didn't took the separate your the data at the very beginning and then build a model on that, you can have a legitimate, very high criticism to say that something went wrong with those data, with this procedure, because they don't know if they are fitting. So that's important way to do. So we did it wrong. We should have put aside some data in order to avoid overfitting. That's the main criticism that you can do. There is another criticism that you can make. It's not the case here, but it could have been the case like 99%, like 95% of your cells were benign, and only 5% of them were malign, which can happen very often. And we can imagine like having a model where you can have 95% of accuracy that is very bad. That is to say, the model that always predicts that it's a benign cell. If each time you see in such a data set where you have 95% of cells which are benign, if you always predict that it's a benign cell, then you will have 95% of accuracy, even if it's a very bad model that always predicts that it's a benign cell and not a useful one. So you also need to be careful about those two kinds of things, and we'll see that both of them on the next day. Okay. So basically, it's all I have to say for today. I will come back in the next video for that will cover the second day of this workshop. Thank you.